Right now, sitting in a NASA clean room and then racing through the void 400 million miles from where you are reading this, a machine slightly larger than a basketball court is on its way to a place that might be the single best chance we have ever had of finding life beyond Earth. And almost nobody outside a small community of planetary scientists understands just how strange and how close we already are to an answer. It is not a red planet with dust storms. It is not a distant exoplanet decades away from any possible visit. It is a moon smaller than our own moon, wrapped in a shell of ice so smooth and so bright it reflects sunlight like a mirror, orbiting a planet so massive that its gravity tears the moon's insides apart with every single pass. Scientists studying it are not using words like promising or intriguing anymore. They are using words like habitable, like plume, like ocean world. And some of them, quietly, in papers you have probably never seen, are using the word life. This is the story of Europa. And here is the part almost no one is talking about. It is not just what lies beneath that ice that should keep you up at night. It is what a spacecraft launched in October of 2024 is going to find out for certain within the next few years, on a timeline that is already locked in, that no human being has ever had before. Stay with me, because by the time this is over, you will never look at Jupiter in the night sky the same way again. I am your name, and this is your channel. Subscribe now if you want more stories like this, because we are just getting started. Let's go back to the beginning, because Europa's discovery is stranger than most people remember. In January of 1610, Galileo Galilei pointed a telescope he had built himself at the planet Jupiter and noticed 4 small points of light that seemed to move night after night in a straight line alongside the planet. He realized correctly that these were not stars, but moons, actual worlds orbiting another planet, and that observation alone helped dismantle the idea that everything in the universe circled the Earth. Europa was the second of those 4 moons, smaller than our own moon, and for more than 3.5 centuries after Galileo first saw it as nothing more than a dot of light, nobody had any real idea what it actually looked like up close. It was assumed to be a dead, frozen, unremarkable ball of ice, the kind of object you file away as uninteresting once you have confirmed it exists. That assumption did not survive contact with real data. It is worth pausing on just how little we actually knew about Europa before any spacecraft ever went near it. Ground-based telescopes could only resolve it as a faint, featureless smudge. Astronomers could track its orbit precisely, but its surface, its interior, and whether it had any activity at all, remained a mystery for generations. Then, in the early 1970s, and again in 1979, NASA's Pioneer and Voyager spacecraft flew past the Jupiter system and sent back the first real images of Europa. And what they showed was baffling even then. Instead of the cratered, battered surface you would expect on an old, dead moon, Europa's surface was covered in long, dark reddish-brown lines crisscrossing the ice in patterns that looked almost deliberately drawn, and there were almost no impact craters at all. On a surface hundreds of millions of years old, sitting in a region of space full of debris and constant bombardment, the near-total absence of craters meant only one thing. Something was resurfacing Europa, erasing the scars over and over again. Something down there was active. But it was not until NASA's Galileo spacecraft arrived at Jupiter in 1995 and spent 8 years studying the system up close that the real picture began to emerge. And this is where the story stops being a curiosity and starts becoming one of the most important discoveries in the history of planetary science. Galileo carried a magnetometer, an instrument designed to measure magnetic fields, and when it flew close to Europa, it detected something that should not have been there according to any model built before the spacecraft arrived. Europa's magnetic field was changing in a way that could only be explained by one specific physical mechanism. As Europa moves through Jupiter's enormous and constantly shifting magnetic field, something inside the moon is generating an induced magnetic field of its own. And the only material that can do that, the only material that fits the data, is a global layer of liquid salt water, conductive, moving, sitting beneath the ice. Not a puddle. not a pocket. A layer of liquid water wrapping around the entire moon, from pole to pole, an ocean larger by volume than every ocean on Earth combined, sealed beneath a shell of ice believed to be somewhere between 10 and 15 miles thick. Sit with that for a second. Beneath a crust of ice on a moon most people have never heard of, orbiting a planet 400 million miles from where you are sitting right now, there is more liquid water than exists anywhere else in our entire solar system outside of Earth itself. And unlike the surface, which sits in a radiation environment so harsh it would kill an unprotected human within minutes, that ocean underneath is shielded, insulated, and by every model scientists have built since, warm enough and chemically active enough to potentially support life. Here's where the story takes its first real twist. Because for years after Galileo's discovery, that ocean remained purely theoretical, something inferred from magnetic field data and surface patterns, but never directly observed. Then, starting in 2012 and confirmed more dramatically in 2016, the Hubble Space Telescope detected something that changed everything. Plumes, towering columns of water vapor erupting from Europa's south polar region, shooting up as high as 125 miles above the surface, roughly 20 times the height Mount Everest, then falling back down as fine, icy particles. If these plumes are real and repeating, and the evidence has only grown stronger since, it means Europa is not just hiding an ocean. It is actively venting that ocean into space, spraying samples of its interior chemistry directly into the path of any spacecraft with the right instruments flying close enough to catch it. Scientists did not need to drill through 10 miles of ice to sample Europa's ocean. Europa might be doing the sampling for them for free on its own schedule. Now, the story gets stranger because before we get to what is happening right now in 2026, we need to talk about what almost never happened at all. For years, a mission to Europa specifically designed to investigate these findings was not guaranteed. Missions to the outer solar system are extraordinarily expensive, and Europa sits inside one of the most lethal radiation environments in the entire solar system, trapped inside Jupiter's radiation belts, which are powerful enough to fry unprotected electronics within hours. Engineers had to design an entire spacecraft around surviving an environment that active systems were never built to survive for long, shielding sensitive instruments inside a vault of titanium and aluminum, roughly a third of an inch thick enough to block the worst of the radiation, without making the spacecraft too heavy to launch. For over a decade, the mission existed mostly as proposals, budget fights, and congressional hearings, a discovery this important sitting on a shelf because nobody could agree on whether it was worth the cost. And then on October 14th, 2024, after years of delays, budget battles, and engineering challenges that pushed the team to the edge of what was considered possible, NASA's Europa Clipper lifted off from Kennedy Space Center aboard a Falcon Heavy rocket, the largest spacecraft NASA has ever built for a planetary mission, carrying 9 scientific instruments specifically designed to answer one question: is Europa capable of supporting life? Right now in 2026, that spacecraft is not sitting in a lab. It is not a theoretical mission. It is physically in flight, moving through the solar system on a path that will take it past Mars for a gravity assist, then back past Earth for a second gravity boost, using the same slingshot technique that carried Voyager past Jupiter and Saturn decades ago, before finally arriving at Jupiter in April of 2030. That is not a typo, and it is not an accident. The distance involved is so enormous that even one of the fastest spacecraft ever launched needs 5.5 years and 2 gravitational slingshots just to get there. Once it arrives, Europa Clipper will not orbit Europa directly, because sitting that close to Jupiter's radiation belts for extended periods would destroy the spacecraft within months. Instead, engineers designed something almost as strange as the moon itself. Clipper will orbit Jupiter in a long, looping path, diving in close to Europa for a single flyby, gathering as much data as possible in the few hours it is near the moon, then swinging back out to a safer distance to protect its electronics before diving back in weeks later for another pass. Over the course of its mission, it is expected to complete around 49 close flybys of Europa, at altitudes as low as 16 miles above the surface, mapping the moon in detail no spacecraft has ever achieved, and directly analyzing the composition of the surface, the ice, and if it is fortunate enough to fly through one, the plumes themselves. Here is the detail that tends to stop people in their tracks once they understand it properly. Europa Clipper is not designed to detect life directly. No instrument on board can identify a living organism. What it is designed to do is answer the question underneath that question, whether the conditions required for life as we understand it actually exist there, right now, beneath that ice. It carries a mass spectrometer capable of identifying the chemical makeup of anything it flies through, sensitive enough to detect organic molecules, the carbon-based building blocks associated with life if they are present in a plume. It carries ice-penetrating radar designed to look directly through the frozen crust and measure its thickness, and potentially detect pockets of liquid water closer to the surface than anyone has confirmed before. It carries a thermal imager to map warm spots on the surface, places where heat from the ocean below might be leaking upward, and a magnetometer built specifically to confirm and refine the ocean measurements Galileo first hinted at 3 decades ago. Taken together, these instruments are designed to determine whether Europa has the 3 ingredients scientists believe life requires anywhere in the universe: liquid water, which the ocean almost certainly provides; the right chemical elements, carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, which the plumes might reveal directly; and a source of energy, which is where Europa's story becomes almost unsettling in how well it fits. Because Europa's ocean is not simply sitting there in the dark, frozen and inert. The same immense gravity from Jupiter that tears at Europa's ice is also flexing and stretching the moon's rocky interior with every orbit, a process called tidal heating, generating enough internal warmth to keep that ocean liquid despite Europa sitting nearly 5 times farther from the sun than Earth does. Scientists studying this process believe it could also be driving hydrothermal activity on the ocean floor itself, vents similar to the ones discovered deep in Earth's own oceans in the 1970s, releasing heat and chemicals into the water above them. On Earth, those same kinds of hydrothermal vents, sitting in complete darkness at the bottom of the ocean, support entire ecosystems that do not rely on sunlight at all. Colonies of tube worms, strange shrimp, and bacteria that build their energy directly from chemical reactions in the vent water. If similar vents exist on the floor of Europa's ocean, the same basic mechanism that supports life in Earth's deepest, darkest waters could theoretically be operating right now, sealed beneath 10 miles of ice, on a moon most people have never once thought about. Now let's talk about what is happening at this very moment in 2026, because the mission is not some distant future story anymore. It is actively underway. As of now, Europa Clipper has already completed its Mars flyby, using the red planet's gravity in early 2025 to adjust its trajectory and pick up speed, and mission engineers used that same close pass to test several of its instruments for the first time in deep space, checking that the radiation shielding and calibration were performing exactly as designed. The spacecraft is now on the long return arc back toward Earth for its second and final gravity assist, a maneuver scheduled to bring it back close to our own planet before it gets slung outward on its final multi-year cruise toward Jupiter. Every month that passes is a month closer to April of 2030, a date that is not a guess or a rough estimate, but a specific calculated arrival window based on the exact physics of the spacecraft's trajectory. The same kind of precision that once told scientists exactly when Voyager would reach Saturn or exactly when New Horizons would reach Pluto. And here's the detail that makes that date significant beyond the mission itself. When Europa Clipper begins its first close flybys in the early 2030s, it will be the first time in human history that we have instruments specifically built to search for the ingredients of life sitting within miles of an ocean world beyond our own planet. Every previous mission to Europa, from Pioneer to Voyager to Galileo, was designed for something else and simply happened to notice hints of what might be there. Clipper is different. It exists because of what those earlier missions found, purpose-built, instrument by instrument, around the single question of habitability. Before I go further, it is worth explaining honestly what this mission will not do, because the exaggerated version of the story is not hard to find online. Europa Clipper is not a life detection mission in the way people imagine when they hear that phrase. It will not scoop up a sample and look for microbes under a microscope. It will not send back a photograph of something swimming. What it will do, if everything goes as planned, is tell us with far greater confidence than we have ever had before whether Europa's ocean actually has the chemistry, the energy, and the stability needed to host life, effectively completing the checklist that would justify an even more ambitious mission afterward, one specifically designed to land on the ice, melt through it, or sample a plume directly and search for biological signatures. In that sense, Clipper is less like the final answer and more like the most important yes or no question we have ever asked a moon. And here's what I want you to take away from all of this, because there is a fact sitting quietly in the middle of this story that is easy to miss once you get absorbed in the science and the spacecraft engineering. Right now in 2026, humanity has a spacecraft in flight, built at a cost of billions of dollars and more than a decade of engineering effort, whose entire purpose is to investigate whether an ocean we cannot see, sealed beneath ice on a moon orbiting a planet 400 million miles away, might be capable of supporting life. We are not guessing anymore. We are not relying only on magnetometer data from the 1990s or blurry Hubble images of possible plumes. We are, at this very moment, physically traveling there to check, on a timeline that ends in 2030, a date already fixed on the calendar, closer than it has ever been before. There are questions about the possibility of life beyond Earth that cannot be answered from a telescope on the ground or a computer model built from a desk. They can only be answered by going there, by flying through the plumes if they are real, by mapping the ice, by measuring the ocean directly. We have exactly one spacecraft doing that right now, crossing the solar system, carrying instruments built for exactly this purpose, and counting down toward an arrival date that will mark the beginning of the most direct search for extraterrestrial life ever attempted. The signal from Galileo's magnetometer 30 years ago was the first quiet knock on Europa's door. Clipper's the moment we finally walk in and start asking questions. The ocean is still down there. The plumes may still be erupting. And in a few short years, for the first time in human history, we may finally get an answer to whether we are alone. If this kind of story is what you come here for, subscribe right now and turn on notifications, because we are going deeper into the outer solar system next time. Drop a comment with what surprised you most in this video, and share this with someone who needs to hear it, because this story deserves more than the silence it is getting. Thanks for watching.